In this section, we are going to be reviewing, because this is a basic algebra topic, graphing lines and writing out equations of lines. We're also going to be incorporating concepts about parallel and perpendicular lines. All of things are topics that we cover in basic algebra. But the only thing that maybe would be different than in basic algebra is that we're going to throw in function notation. So this is going to be primarily a review, and then we'll also include the function notation with it. All right, so let's go ahead and get started. So we are going to look at graphing a couple of lines here, and there was always lots of different methods to graph a line. So let's say we start with f of x equals negative 1/2 x. And so maybe you've forgotten altogether that this was a line. So suppose you didn't even know what this was a graph of. And we're going to, in this chapter, move into other types of graphs, things that aren't lines. And so one of our tools we never want to forget about is an ability just to sub in and plot points to come up with, hopefully, then what the shape of the graph is we're looking at. And so a good selection of points would involve some positives, some negatives, and 0. So let's say I start by doing just that in this case. So negative 1/2 times 0, I'm going to start in the center, would be 0. Negative 1/2 times 1 is negative 1/2. Negative 1/2 times negative 1 would be positive 1/2. And then negative 1/2 times 2, the 2's would reduce, I'd have negative 1. Negative 1/2 times negative 2 would be positive 1. And while you're certainly welcome to plot those fractional values, it's probably easier if we stick with the integer ones. So negative 2, 1, 0, 0, and 2, negative 1. And of course you could plot in the other ones, negative 1/2 over 1 down 1/2. And yeah, it looks like everything's kind of falling in a line. Hopefully you remember when you have all x to the first power terms, y to the first power terms, and constants, that is when you have a graph of a line. And so this is certainly looking like I have, like I said, the graph of a line. So I'm just going to go ahead and just do my best freehand impression here of graphing this line. And so roughly something like that. So this is going to be my function here, f of x. All right, so now maybe we remember just a smidgen more, and let's say we're graphing y equals negative 1/2 x plus 4. So this time let's graph with our slope-intercept technique. So remember, this is in the form of y equals negative 1/2 x plus 4. Of course, that's the y. And what I actually meant to write was we're in the form of y equals mx plus b. And so the first thing that we do is we plot that b on the y-axis. So we are going to go to 4 on the y-axis, and we are going to plot that y-intercept. So that's what we did first. And then the second thing that we are going to do, so our second step here is going to be to use the fact that the slope is equal to this negative 1/2. And so that means we go up or down the numerator, and then write the denominator is typically what we would do. It's a rise over run ratio. So a lot of times we just naturally group the negative with the numerator. So we're going to look at that negative 1 with the numerator and say, okay, that means we're going to go down 1, and then we lump the 2, or look at the 2 in the denominator, and that tells us we are going to go to the right 2. So from that point, we go down 1 and to the right 2. So that's what we obtained second. But of course, the whole idea, once you have that slope, is you can continuing extending your slope, going down 1 over 2, or in reverse, up 1 into the left 2. I actually realize I went over one too many right here. All right, and so that is, even 2 points is enough to graph a line, but that is my function g of x. So again, hopefully this is all ringing a bell, and we're just kind of, the only difference is maybe we're calling them with the function notation. All right, a couple of the special cases. Well, another thing, let's observe those two lines are parallel because they have the same slope. So that's something that we'll come back to as parallel and perpendicular lines. We'll recap those as well. All right, so now let's look at another example here. Suppose we were looking at number 2. Let's say we were going to graph f of x equals -4. So remember, that's the same thing as saying y is -4. And so in this case, there's no x-coordinate. So if you were thinking about, just what are points that would satisfy this equation, it's anything where the y-coordinate is -4. As long as that y-coordinate is -4, you have satisfied the equation. You could pick whatever you want for the x value, and again, you have satisfied your equation as long as the y-coordinate is -4. So what we end up with here, oh yeah, hopefully this all rings a bell, y equals a number when there's no x-coordinate. That is the equation of a horizontal line. So here's our horizontal line, y equals -4. And let's also graph on this one the other case, the other special case of x equal a number. So in this case, if I wanted to think about some points that would satisfy the equation, I just need to make sure the x-coordinate is 1. The y-coordinate could be whatever we want it to be. That wouldn't matter as long as the x-coordinate is 1. So I could plot, some points that way, and pretty quickly, hopefully we see, oh yeah, when it's x equals a number, when there is no y variable, that is when we end up with what was supposed to look like, and I got a little crooked there, what's supposed to be a vertical line. So we end up with this vertical line, x equals 1 here. All right, so kind of recapping a lot of things that we've just used and some things that we're going to use. Slope, there's the formula, it's that rise over run, change in y over change in x. We have a few different forms of line, the standard form, x and y term on one side, plane number on the other. Probably the preferred slope-intercept when you solve for y. Then the m in front of the x is the slope and the b is the y-intercept. That's what we use in number 1. One way to find an equation of a line would be to use this point slope formula. We'll look at some examples of that in just a little bit. And then lastly, we just did an example of the two special cases. Y equals, or f of x equals a number, that's a horizontal line. If you have x equal a number, that is a vertical line. And just kind of notice that the vertical lines would obviously fail the vertical line test. You have a lot of repeated x-coordinates there. So the vertical lines are the only lines that are not functions. Every other line we could replace with a function notation because they're all going to be functions. But the vertical line, the one case that is not. All right, so that's a kind of a quick recap of some graphing. What we want to move into next is going to be finding some equations of lines, and let's maybe take a look at that next time.